to Lecture 8 of Computer Programming Fundamentals, L8, Modular Computer Programming using C. Now that we have demonstrated the three families of control structures, given computer program code models L7A.C through L7F.C, let's further focus on the development of reliable computer programs. Reliable computer programs that not only emphasize structured programming best practices, but extend structured programming best practices by producing modular computer program code that is not only reliable, but is maintainable as well. Computer program code model L8.C is used to demonstrate this modularity by organizing computer program code models L7A.C through L7F.C into one single computer program code model, namely Computer Program Code Model L8.C, where L8.C contains a separate function for each of the computer program control structures, previously demonstrated by Computer Program Code Models L7A.C through L7F.C. Thus, each control structure is treated as a separate module within Computer Program Code Model L8.C, a separate module that is called from within L8.C's main function definition. This isolation of the proven computer program code models, already proven by Computer Program Code Models L7A.C through L7F.C, are now isolated to improve computer programming code and maintainability. What's more, modularity of computer program code, combined with proven reliability, leads to computer program code reuse, where reuse is the foremost feature of today's dominant computer programming languages. Dominant computer programming language is based on the computer programming language object-oriented paradigm, those supported by robust libraries of proven functions that can be reused effectively by computer program developers, given they are included in the developer's computer program code in a manner that stresses modularity. Next, let's take a closer look at Computer Program Model L8.C, reliable computer program code organized effectively into one single computer program that demonstrates modularity. Before the functions representing each of the computer program code models can be executed, that is, the control structures demonstrated by code models L7A.C through L7F.C, these functions must be first declared. Hence, the Computer Program Declaration section of the L8 Computer Program Code Model, namely /function declarations, L7A, left paren, close right paren, semicolon, L7B, left paren, closed right paren, semicolon, L7C, left paren, right paren, closed, semicolon, L7D, left paren, right paren, closed, semicolon, L7E, left paren, right paren, closed, semicolon, L7F, left paren, right paren, closed, semicolon, where the /function declarations is a line comment documenting that the function declaration computer instructions follow. Note the naming of each function uses the same name as the associated computer program code models, used in Lecture 7 to demonstrate each structured programming computer program control structure. Let's take a look at the first computer program declaration instruction, namely L7A, left paren, closed right paren, semicolon. Note here that the function is named L7A. Function L7A, when executed, does not return a value. This is evident as there is no data type preceding the function name. Additionally, when the function L7A is called, there are no arguments passed with the function call. Note the closed parentheses following the function L7A name. As such, no data variable parameters are declared with the function declaration, indicating no data variable arguments will be passed when function L7a is called. Thus, in this case, we have a standalone function which mirrors the exact computer programming code of computer program code model L7a.c. In fact, L7a function definition contains the identical code to computer program code model L7a.c. No surprise, as it was copied directly from L7a.c and pasted into computer program code model L8.c, pasted under the L7a function header section of L8.c. As such, L7a.c's computer program code has been ported to computer program code model L8.c as a standalone function or module that is reused without modification because its reliability and authenticity has already been proven. In conclusion, everything discussed for function L7a holds for functions L7b through L7f. Next, I will discuss how these functions or modules are called. Now that the functions L7a through L7f have been declared, they can be executed by calling them from within the main function definition. As such, let's take a look at the computer program instructions included in main, namely /mainline, our mainline comment, main left paren, right paren, left brace, printf, left paren, double quote, L7a.c sequence, input, process, output, /n, double quote, right paren, semicolon, L7a, left paren, right paren, semicolon, printf, left paren, double quote, L7b.c, for loop repetition control structure, fixed number, /n, double quote, right paren, semicolon, L7b, left paren, right paren, semicolon, printf, left paren, double quote, L7c.c, do while loop, decision after repetition, /n, double quote, right paren, semicolon, L7c, left paren, right paren, semicolon, printf, left paren, double quote, L7d.c, while loop, decision before repetition, /n, double quote, right paren, semicolon, L7d, left paren, right paren, semicolon, printf, left paren, double quote, L7e.c, if else, decision for just one of two choices, /n, double quote, right paren, semicolon, L7e, left paren, right paren, semicolon, printf, left paren, double quote, L7f.c, switch, multiple choices, left paren, do case, right paren, /n, double quote, right paren, semicolon, L7f, left paren, right paren, semicolon, right brace. First, note that the function calls are the only computer instructions included in the main function definition, beside the printf function calls displaying on the console the function currently being executed. Thus, the execution of all the function modules is controlled from one location, that one location within the main function definition. This portion of the computer program code model L8.c, called the main line of the computer program, given this organization of computer program code model L8.c, the already proven function control code models L7a through L7f are isolated and preserved in their original unaltered form. Thus, reliable computer program code is organized into a hierarchical top-down structure called from computer program code model L8.c's mainline. Here, the mainline directs, controls, and executes the reliable code. As such, this organization structure of your computer program ensures that reliable, authentic, and proven computer program functional modules are utilized effectively within your specific computer program. This not only ensures effective reuse of computer program code, but also enhances the maintenance capability of your specific computer program code, as demonstrated by the hierarchical organization of Computer Program Code Model L8.C. Since the mainline computer program instructions are identical for functions L7A through L7F, let's just take a closer look at those computer instructions for function L7A, namely printf, left paren, double quote, L7A.C, sequence, input, process, output, \n, double quote, right paren, semicolon, L7A, left paren, right paren, semicolon. The first computer instruction is merely a printf function call to display on the console that the function demonstrating the sequence control structure result will next be displayed on the console. The second computer instruction is the function call for the L7A function. Next we take a look at the console result from calling and executing all function modules, namely L7A through L7F, where you will see the rationale for using the printf function call to track the display results for all the 7 functions. Now that functions L7A through L7F have been executed, let's take a look at the results for all 7 functions executed in sequence from Computer Program Code Model L8.C's mainline. Note the display header on the console preceding the results for each function. The display header identifies the function results that follow. For example, for function module L7A, L7A.C -sequence -input /process /output. This is displayed on the console by the execution of the printf function call, printf left paren double quote L7A.C -sequence -input /process /output \n double quote right paren semicolon, following the display of L7A.C -sequence -input /process /output, we find the result of function L7A's execution, where data variable num is 56 and last name is Kubli. Note that in each case the console display shows that I entered the data variable values for num and last name. The function results for function modules L7B through L7F are displayed similarly, so I will not go into any further detail on these at this time. Rather, next I will show each functional module individually with its command processor results to demonstrate how Computer Program Code Model L8.C's hierarchical top-down organization improves computer program maintenance, reuse, and reliability. Now that functions L7A through L7F have been executed, displaying on the console the results for all 7 functions, let's take another look at the mainline code of Computer Program Code Model L8.C. Note the block comment pair that I have inserted, namely beginning block comment indicator /*, followed by the ending block comment indicator */. Note that the block comment blocks the computer program instructions associated with the calls of functions L7B through L7F. Thus, these computer program instructions between the beginning and ending block indicators, namely computer program instructions printf left paren double quote L7B.C -for loop -repetition control structure -fixed number \n double quote right paren semicolon through L7F left paren closed right paren semicolon are blocked. The compiler ignores these computer program instructions because they are included as a block comment. As such, the computer program instructions are considered comments In other words, a non-executable portion of the computer program code model L8.C. Commenting out viable computer program instructions, otherwise known as no-opting of computer program code, is a common technique for isolating, debugging, and maintaining proven function modules. However, if your computer program is not organized properly, that is, not organized in a hierarchical top-down manner, featuring a well-structured mainline from which the function modules can be called, then the absence of the proper computer program organization makes the no-opting technique useless. In closing, the development of reliable, maintainable, and reusable computer program code not only requires compliance with structured programming best practices, but more importantly requires an effective overall computer program organization. An effective overall computer program organization with a mainline set of computer instructions, a mainline that effectively controls the execution of the proven reliable function modules. As such, in this case, only the computer program code of function module L7A is called and executed, whereas the computer program code associated with function modules L7B through L7F is blocked.